Hello and welcome to this video on the IUPAC nomenclature of alkenes and alkynes. In this video, we're going to talk about the nomenclature of alkenes and alkynes. And the reason I've taken them together is because in this video, we are going to look at how we do the naming of alkenes and what happens when there are more than one double bonds, what happens when there is a triple bond, more than one triple bond, and when there is double and triple mixed together. So we're going to see all those details in this particular video. The first thing that we need to understand is that the name of an alkene is similar to the name of an alkane, with the difference that instead of that A and E, you put E and E at the end. So if it is butane, if it was butane, you put butene. So A and E is replaced by E and E. So that's the first point that we need to look at. So unsaturated, unbranched, acyclic hydrocarbons having one double bond are named by replacing the ending "ane" of the name of the corresponding alkane with the ending "ene." So the "ane" becomes the "ene." And what we need to understand is we are talking about unsaturated and we are talking about unbranched. We're talking about acyclic hydrocarbons. So, and these are the ones in which I'm assuming there is a double bond. So when there is a double bond, we call it an alkene. Now, if there are more than one double bonds, if there are two or more double bonds, then we use the term adiene, atriene, etc. So if there are two double bonds, it becomes adiene, atriene. So it is remove this ane of alkane and put adiene, atriene. So when there is more than one double bond, it becomes alkadyne, three double bonds, alkatrine, etc. So if there are two or more double bonds, the ending will be adyne, atrine, etc. The generic names of these hydrocarbons are alkene, alkadyne, alkatrine, etc. Now, then comes the location of the double bond. Now, we always ensure that the numbering is done from that end or the parent chain. In fact, okay, let's talk about the parent chain a little later. Let's assume if you want to number it, numbering has to be done from that end of the parent chain such that the double bond gets the lowest number. Now, obviously, the double bond exists between two carbon atoms, something like this. So if you number it from this end, let's say, suppose you have another carbon here, 1, 2, 3. So the double bond is between 2 and 3. If you number from this end, it comes between 3 and 4. So we will try and number it from the right side in this particular case so that we get the lowest number for the double bond. And we mention only the lower of the two numbers that are given. So the chain is so numbered so as to give the lowest possible numbers to the double bonds. The lower of the two numbers is mentioned before the name of the alkene. And the way the name is mentioned is if it is, let's say, if n is the number of the carbon on which the double bond exists, we name the alkene as alkene. Now, in the older version, it used to be named as N-alkene. But the newer naming says that since we really want to give emphasis on the double bonds, so we say, okay, alkene. Now, what happens if there are more than one double bond? How do we give the numbers? Again, give the numbers in such a way that both the double bond get the lowest numbers. And you mention the lower of both the numbers. And this is the way you mention. And remember, it's a diene. So let's say if it is butadiene, I say buta N M diene, where N and M are the numbers of the two carbon atoms on which the two double bonds exist, and they have to be written in the increasing order. So this is the way you number it. So let's try and see a couple of examples. For example, how are you going to name this one? Pause the video, name this, and then try to figure out whether your answer is correct or not. Now what you do is, how do we number this? We will number this from here. 1, 2, 3, 4, 5, 6. Since there's no branching, so there's no confusion here. There is only one parent chain. And of course, I'm going to talk about how to decide what is a parent chain. So here it is hexene, as you can see. 6 carbon atoms and there's one double bond. And the double bond is located between 2 and 3. So we only mention 2. So this particular name becomes hex 2-ene. Let's try something with 2 double bonds. Now where are you going to number this from? Obviously, you're going to again pause this video, try and do the numbering, try and do the naming, and then check it out. We are going to number it from the right side. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Because I get the lowest value 1 and 4. If I were to number it from this side, the numbers would be bigger than 1 and 4. So I'm going to number it from the right side. So what would be the name of this? Now remember, it's a diene. It's a double bond, a diene, 2 double bonds. So what we're going to do, it is hexadiene. So we're going to say hexa, pause, and then we're going to talk about the 2 numbers hyphen 1, 4 diene. So it's going to appear like this, hexa 1,4 diene. Now for some of the simple alkenes, certain common names are retained as IUPAC names. So for the molecule which we call as ethene, we can use the common name ethylene, and ethylene is accepted as IUPAC name, and as well as for alene. This particular molecule has a common name alene. If I were to give it through IUPAC, I would give it as 1, 2, 3. This is prop 1, 2 diene. It's propa 1, 2 diene. And its common name is alene. And we mention alene as the IUPAC name for this particular molecule. Now, suppose you have something similar for alkynes. Now let's look at the triple bond. The ane of the alkane is replaced by ine. So unsaturated, unbranched acyclic hydrocarbons having one triple bond are named by replacing the ending ane of the name of the corresponding saturated hydrocarbon with the ending ine. So ane replaced by ine. And again, if there are more than one triple bonds, we use the term a diene, a triene, etc. So if there are 2 or more triple bonds, the ending will be a diene, a triene, etc. The generic names of these hydrocarbons are alkyne, alkadiene, alkatriene, and we will give the numbers in the same way as the double bond. So the chain is so numbered so as to give the lowest possible numbers to the triple bonds. Only the lower of the triple bond number is mentioned. And the simplest of the alkyne is ethyne, whose common name is acetylene, and we can retain the common name as the IUPAC name. Then comes the situation when you have both double and triple bonds together. So how do we do this? Now here you need to understand something. You have an alkene, you have an alkyne. You have both of them together. So how are we going to sort of look at naming when both of them are present? Now remember, uh, this particular word is pronounced as ein. Though we have y here, the sound that is produced when I say ein, it it seems as if it starts with a vowel. So whenever you have, and remember, what you need to do is, whenever you name a double and a triple bond together, first name the double bond, then name the triple bond. So the ending is going to be ein. And before ein, you're going to have this fellow, in. But since this is beginning to sound as if it is starting with a vowel, we will remove this e here. So it becomes n, ein. So it is alken, ein. And since we also have to specify the numbers, it will be alk, n, n, and this particular n is the number of the double bond, m, ein. So alk, n, n, m, ein. Now, if suppose I've got two double bonds and one triple bond, so it is going to be alka, n, m, di, n. Again, from the diene, we remove the e because remember it is going to end with ein, sounds like a vowel. Whenever something sounds like a vowel, you remove the last vowel of the preceding suffix. So diene, I remove the last e, m, ein. Now suppose if there are two triple bonds and one double bond. Since there are two triple bonds, it is going to be diene. Now diene definitely doesn't sound like a vowel, as if it is beginning like a vowel. So I'm going to retain the e of the alkene. So this is going to be alkene diene. So with the numbers, it will be alk, n, in, a, b, diene. And you have to put a diene here because it's a diene. So let's figure out how to name this. Unsaturated, unbranched acyclic hydrocarbons having both double and triple bonds are named by replacing the ending "ane" with "ene", a diene, a triene, "ene diene", and a diene. Now remember, if both of them are 2, you put the a only once here. So it is alka, a, b, diene, and diene in fact, because the next one is also a diene, c, d, diene. And we'll be able to get this once we see a couple of examples here. The numbering has to be done so that the lowest number is given to double and triple bonds. And it doesn't really matter which one you give the lower number to, as long as the lowest you can give both to the double and the triple bond. The first unsaturated bond must get the lowest number. That's the basic deal. The deal is that if you are going to number it. Let's say, for example, you have something like this. If I number it from the left side, the first unsaturated bond gets 1. If I number it from the right side, the first unsaturated bond comes at 2. I'm going to number it from the left side. So what we need to understand is that the lowest number must first appear for the first unsaturated bond. That's the basic deal. So numbering is done in such a way that the lowest possible number is given to the first unsaturated bond. Now, in case there is a choice in numbering, that means either way you get the same thing, then you try and give the lowest number to the double bond. Double bond is given the preference. So when there is a choice in numbering, the double bonds are given the lowest numbers, written as alk and N-M ine. So let's try this. Pause the video, number it, name it, and check. So this is the way we're going to go. When I start giving the numbers, let me try from the right side first. 1, 2, 3, 4, 5, 6. Do the reverse way. 1, 2, 3, 4, 5, 6. Now if I go from the top, my first unsaturation is at 1, then 3, then 5. Go the reverse way, first unsaturation at 1, then 3, then 5. Now here I have a choice of numbering. Either way I get the same stuff. So I would prefer to give the double bonds the lowest number. So that means I'm going to pick up this numbering. So the numbering is done like this. So how are we going to write the name? The name is going to be, it's hex, okay, 6 carbon atoms, it's hex. And the first one is an alkene and it has to be hexa, because you're talking about a diene. Hexa 1, 3 diene. Remember, you're not going to have the last E because the next one is an ine. Sounds as if I'm pronouncing it with a vowel. 5 ine. So the name goes like this. Try this one. Pause the video, check for yourself, and then play the video and check whether your answer is correct or not. Now here, if I number it from the top, I get 1, 2, 3, 4, 5. First unsaturation at 1, then at 3. Go the reverse. 1, 2, 3, 4, 5. First at 2, second at 4. It doesn't work. We go with 1 and 3. So though we are giving a lower number to the triple bond, that is because the first unsaturated bond must get the lowest number. So the numbering is done like this. And this is a simple one, 5 pent. And you have a 3N and 1 ine. Now in case, now let's do the a bit of a complication. In case you have substituents, then the substituents would always occur before this particular parent name. So unsaturated branched acyclic hydrocarbons are named as derivatives of the unbranched hydrocarbons. Now comes the question, how do we select the parent chain? The most important part. So the parent chain is selected based on the following rules. The first rule is you have to select that chain which has the greatest number of unsaturated bonds. When I say unsaturated bonds, I mean to say double plus triple. The total number of double plus triple should be maximum. The chain with greatest number of unsaturated bonds. Now suppose you have more than one chain, which is double plus triple equal to same, but the number of double and the triple may change. Then you have to select that which has the greatest number of carbon atoms. If the double plus triple is same, then go with the maximum number of carbon atoms. If carbon atoms is also same, then go with the one which has maximum number of double bonds. And this, I'm sorry, this has to be point number 3. So the chain containing maximum number of double bonds. And always remember, the numbering has to be given based on the fact that the first unsaturated bond must get the lowest number. Not the substituent, but this one. It's only when the choice of numbering exists that one can go for lower number for the substituents. So let's check out a few molecules and their names. As usual, pause the video once the structure comes out complete. And yeah, that'll be it. So now pause the video, name it, and then check the name. Now, which chain do you think is the parent chain? Obviously, it has to be this one. This is the one which contains maximum number of double plus triple. There are 3 double plus triple bonds. So I'm going to select this chain as the parent chain. All right, parent chain selected. How do I number it? Try it both ways. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, in the first one, I get the unsaturation at 1, 3, and 5. Second one, I get at 1, 3, and 5. And when the choice of numbering exists, you always go with the preference to the double bond. So we go with this particular numbering. So the numbering will be 1, 2, 3, 4, 5, 6. In 3, I've got a propyl group. In 4, also I have a propyl group. So it's going to be 3, 4 di. Now let's understand. 3, 4 dipropyl. That's we are okay with the substituents part. So how do we name the parent? The parent, you can write the parent separately. It is hexa 1, 3 di-N 5 ine. This is the parent. And sorry, it's a di-N. You can't have a E. Remove this E. So it's a di-N 5 ine. And then before this, you just insert 3, 4 dipropyl. So it goes like this: 3, 4 dipropyl hexa 1, 3 di-N 5 ine. Try this one. Parent chain. Obviously, this one. Numbering doesn't matter, but yeah, it matters because 1, 2, 3, 4 is an option. 1, 2, 3, 4 is another option. In the previous one, unsaturation is at 1 and 3. Second one, unsaturation at 1 and 3. Both are double bonds. So now I give preference to the substituent. So in this particular numbering, the substituent got number 2. In the numbering from the left side, it got number 3. So I prefer the numbering from the right side. So the numbering is done like this. This molecule now becomes 2-methyl buta 1,3-diene, and its common name is isoprene, which can also be used as an IUPAC name. Now let's talk about situations when the branching itself contains double and triple bonds. So if the branching itself contains double or triple bonds, then it goes like this. Now we know that if it is a branching of a saturated carbon, we remove alkane A and E and put alkyl. Ane removed, put YL in it. Similarly, if it is alkene derived, we put alkenyl. Alkenyl. Alkynyl. Remember, remove the last E. From the ene, remove the last E because the il sounds as if it is coming from a vowel. Okay? So now what about two double bonds in the side chain? Dienyl. Two triple bonds. Dienyl. That way. And again, remember the carbon attached to the parent chain is numbered as 1. So rule number 15 says the names of substances derived from unsaturated acyclic hydrocarbons have the endings anyl, inyl, dienyl, the positions of the double and triple bonds being indicated wherever necessary. The carbon attached to the parent chain is numbered as 1. And if the side chain is attached to the parent chain with a double bond, now let's assume this is a parent chain. Suppose you have a side chain attached like this, and assume there are a lot of double and triple bonds here, and therefore you have to consider this as the parent. So this particular side chain, this particular branching would be called alkylidene. Alkyl lydene. And if it further contains double bonds, alkynylidene. Alkynylidene. Now let's get this rule, and once I show you some examples, you'll be able to understand them better. So we'll see some examples now. So if the side chain is attached to the parent chain with a double bond, the substituent is named alkylidene, alkynylidene, alkynylidene. Let's check this out. If this were a side chain, what would you call it? What would be its name if it were a complete hydrocarbon, a complete molecule in itself? It would be ethine. And now it's a side chain, we call it ethinyl or ethinyl. What about this one? Now remember, it is attached with this carbon atom. So this is 1, 2, 3. Derived from propyne. So it's prop-2-inyl. Prop-2-inyl. Because otherwise, see, if it was simply propyne, then we don't have to specify the number. Because propyne can only be this. But if it is this, you'll have to specify the number because this is the carbon 1. So prop-2-inyl. Try a few of them on your own. What would be this? This is again a propene thing, but this is 1, this is 2, this is 3. So prop-1-enyl. Try this. What is this? 1, 2, 3, 4. So what would you call this? It's butene. But-2-enyl. How about this one? Isn't it a butadiene? So buta 1, 3 dienyl. Try this. 1, 2, 3, 4, 5. and this becomes pent 2N 4-inyl. This one we can call it ethenyl. We can also call it vinyl. What would you call this one? 1, 2, 3. This is prop 2-enyl. It's also known as allyl. What would you call this one? You would call it as 1, 2. So you would say 1-methyl ethenyl, also known as isoprenyl. You can also call it 1-methyl ethenyl, or you can also call it isopropenyl. Now remember the side chains with the double bonds? Now directly attached to a double bond. Now remember we called it as alkylidene. So this is derived from methane, methylidene. And what happens if you have this situation? Well, this is ethene, right? It is ethene with this double bond. And to indicate this double bond, we have lydene. Methyl is the normal one. Idene is supposed to indicate the double bond. That is joined to the parent chain with the double bond. So this thing is taken care of by idene. So what is the rest? It's ethene. Since it's a side chain, ethenyl lydene. So what would you call this one? Well, I think this is defined by IDENE, and this is simply ethyl group, so it should be ethylidene. Alright, how about this one? Well, this double bond is taken care by idene. So this is 1, this is 2, this is 3. Forget about this double bond right now. This is prop 2-enyl lydene. Prop 2-enyl lydene. What do you call this one? Well, IDENE takes care of this double bond. Now forget about this. Prop 2-enylidene. Okay. So that is the way you name them. So let's look at a couple of more namings, and maybe this will become more clearer. Try this one. Yeah, that's it. So now pause the video, name it yourself, and check. Remember, the first thing is find the parent chain. Look at the rules back again. The first rule for parent chain was maximum number of double plus triple bonds. It doesn't matter how many double bonds it has, maximum double plus triple. If there is a choice in numbering, if that doesn't help, then you go with maximum number of carbon atoms. If that doesn't help, maximum number of double bonds. So which is the chain which contains maximum number of double plus triple? Now let's look at this one. 1, I'm not right on numbering it, but I'm just writing the number so that I can find out the number of carbon atoms and everything. Now in this situation, I've got 3 double plus triple and there are 7 carbon atoms. Suppose I made this as 5 and this is 6 and this is 7. I would have still had 3 double plus triple and I would have still had 7 carbon atoms. So the first point of double plus triple doesn't work because both of them have 3. The maximum number of carbon atoms doesn't work because both of them have 7. So the next thing is, the last thing is, look at the maximum number of double bonds. Obviously, it has to be this one. So what's the numbering? How do you do the numbering? Numbering we do from the right side so that all the double bonds can get the lowest possible number. Now, which is this one? This is derived from ethyne, ethynyl. So 5-ethynyl hepta 1,3,6 triene. Try this one. Try it on your own. Now this is pretty simple. It's got only one double bond. So numbering has to be done from the right. So 1, 2, 3, 4, 5, 6. 5,5-dimethyl hex 1-ene. Try this. Check for yourself. First, remember parent chain. Now, if you look at this one, double plus triple is 2. Look at this one, double plus triple is still 2. But the second option is go for the maximum number of carbon atoms, not the maximum number of double bonds. That's the third point. The second point is maximum number of carbon atoms. So we're going to select this one. Numbering from the right side so that we get the lowest number. Now which one is this? Substituent. It's vinyl, ethynyl. So it's 4-vinyl hept 1N5-ine. So I think you must have gotten a little bit of hang of this particular thing. Now the last part that is left is what happens if the side chain itself is very complicated. The side chain itself has a lot of double and triple bonds. Well, the choice of numbering, the choice of parent chain, everything remains the same. So when there is a choice for the fundamental chain of a substituent, that chain is selected which contains the maximum number of unsaturated bonds, the largest number of carbon atoms, and the largest number of double bonds in that particular order. For example, try this. Remember, it's a side chain. We're talking about we are talking about the branch. This complete thing is a branch in a parent chain. So what would be this branch called? To call this branch, you need to first locate the fundamental chain of the branch. Again, what is the logic? The maximum number of unsaturated bonds. So where do you find the maximum of unsaturated bonds? It is this one. There are 4 of them. So the numbering, and obviously this automatically gets number 1 because it is the one attached to the fundamental chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the branch of the branch is named like this. Now look at the complication in this. This particular thing is the branch of the branch, and that also contains a double bond. So what would you call this branch of the branch? Because this has to be named first. So we call it's pentene, and it's on the point 3. So pent 3-N-nyl. Pent 3-N-nyl. So that is the branch of the branch, and this entire thing, this fundamental chain of the branch, this is 3, 6, 8, and this is deca. So this is triene. Okay, so it is deca and 3, 6, 8 triene 1-ine-nyl, because this entire thing is a branch. The whole thing is a substituent. So it is named like this. So just check out with your name and check to see whether it's working or not. Try this one. Remember, it's a branch. This entire thing is a branch. So we are looking at what happens if the branch is so complicated. Which one do you think is the fundamental chain of the branch? Now, if you go from right to left, if you go this way, I think the number of double plus triple is 4. You go this way, the number of double plus triple is still 4. So look for the maximum number of carbon atoms, which I think should be in this one. So, and the numbering obviously has to be done from the right side because that is automatically 1. So numbering is not an issue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is the branch of the branch. Look at how complicated the name is going to be. This branch, how do you name this? It is pent 1,3-dienyl. So it's pent 1,3-dienyl, and this is located at 6th carbon. So it is going to be 6, and you're going to have all of this in a bracket. And it's 12 carbon atoms, so it is do, deca, because you have 3 double bonds, 2, 4, 7, tri-N, 9, I-nyl. That is how the naming should happen. And a couple of more examples of this. So that we can get used to this. Again, remember, this entire thing is a branch. You're going to find the parent chain of the branch. So please name it and pause the video and check for yourself. Parent chain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's undeca. And the substituent will be named as pent 1,N,3-inyl, located at carbon 6, undeca 2, 4, 7, 9, tetra enyl. Remember, don't forget the enyl in the end, because this entire thing is a substituent. The last molecule coming up is this one. Name it, pause the video, name it. First find the parent chain. Remember, this is automatically carbon 1. And again, maximum number of double plus triple bond, and there is only one chain here, which is this. This may contain more carbon atoms. Doesn't contain both the carbon atoms with the double bond. Remember, the parent chain must contain all the carbons of the double and triple bonds. So 1, 2, 3, 4. And there are 9 carbons here, so it's nonyl. To this 2-nonyl but-2-enyl. So I hope this video would help you in understanding the nomenclature of alkenes and alkynes. Go through this video as many times as you need to train yourself, because it's going to take a while. It's not just going to happen overnight. Just by looking at it once, it may not work. Do it again and again. Take your time. Try as many examples as you can, and then check for yourself whether you're able to name them or not. And I really hope that this video helps you. Thanks for watching.